Hey guys, this is LeetCode 13, Roman to integer. Roman numerals are represented by 7 different symbols. So this is the map of symbols from Roman to integer. For example, 2 is written as these symbols here in Roman numeral, just 2 ones added together. 12 is written like this, which is simple 10 plus 2. The number 27 is written like this, which is 20 plus 5 plus 2. Roman numerals are usually written largest to smallest, from left to right. However, the numeral for 4 is not like this. Instead, the number 4 is written like 1 following by 5. Because the 1 is before the 5 we subtracted, making 4. The same principle applies to the number 9, which is written 1 followed by 10. There are 6 instances where subtraction is used. So there are these instances here for 4 and 9, 40 and 90, and 400 and 900. So given a Roman numeral converted to an integer, input is guaranteed to be within the range from 1 to 300,999. So there are some examples here. And yes, so I think this is easy because we can construct a hash map like this, and as we are iterating through the input, we can check if we find a current character into this hash map. But we have to care about these instances here, and I think we can handle this in 2 ways. We can handle by checking if the current character is, let me see, if it is equals or smaller than the next one. If it is, we can, let me see, actually if it is smaller, we can subtract the current character and from the result. And the other way, we can just put these instances here in our hash map and check if we can find the current plus the next character into the hash map. Otherwise, we can just add the current character. We can search into the hash map the current character and add it into the result. Okay, so I think I will go with the second solution, which I will create an instance for all these instances here in the hash map. Okay, so let's see if this works. Let's try to write some code. Let's start by checking if our input is valid. So if s.length is equals to 0, we can just return 0. Otherwise, we can create our hash map. So let's create as a map is equals to new dictionary of string and int, and we are gonna add all this table here into our hash map. So we have our add for number I in Roman, which is 1, and we are gonna do this for all of our Roman characters. So 5 here will be 5, 10 will be 10, 50 will be 50. Now we have the 100. Now we have 500 and 1000. And as I said, we will also handle here the Romans that has two characters, which the first one is smaller than the next one. So here we will have the 4. Here we will have the 9. Here we will have the 40. Do remember the 40 is XL, which is 40. And here we will have the XC, which is 92. And here we will have the 400, which is C placed before D, which is 400. And here we will have the C before M, which is 900. Okay, so we have our table. Let's just check if it is right. So 1, 4, 5, 9, then 40, 50, 90, 100, 400, 500, 900, 1000. Okay, I think it is. Now we have to iterate through our input. We can do this by doing a for loop. So for equals 0 while I is less than s dot length I plus plus. And as I said before, we need to check if the current and the next character together exist in our hash map. We also need a result variable. Okay, so let's start by checking if I plus 1 is still a valid index in this input. So is less dot length. And if let me see, how can we do this? So if map dot contains key, I will break this line here. Map dot contains key of s dot substring starting at I and getting 2 characters. So if this exists, what we have to do? We have to add the result. We need to add the current value into this hash map into the result. So we'll get the key of s substring starting at I and getting 2 characters. And also we have to add 1 to the current index, because in the next iteration the for loop will increment 1, but as we are getting 2 characters here, we also need to handle this inside this if statement. Otherwise, we just need to add the current character to the result. So we need to get map of s dot substring of I getting 1 character. Okay, so I think if we do not have any typo, we just need to return the result variable here, and that's the solution. Let's check. This is wrong. This is a method. Yes. Okay. Yeah, that's it. Let's try another example. Okay, let's try hit submit. Okay, so that's it, guys. The time complexity for this solution is big O of n, where n is the length of our input here. The memory complexity is constant because we are allocating a constant space here for the dictionary, but this does not relate to the growth of the input. So it doesn't matter how big or how small is the input, we will always allocate this amount of memory for this solution. So that's it. Thanks for watching.